Thanks for tuning in at Brackies.
Hello everyone and welcome to video number 12 in Make a Game, a cool series on making a video game in Unity. Today we have a bunch of things to do. So here's the to-do list. We have to fix a bunch of things, just tweak some settings, and we're gonna add some cool visuals. So I've made a model and added some normal maps. So we're gonna talk about all that. This video might be pretty long, but we're just gonna have at it, and if it gets too much, I'll split it up into parts. But before we get started, I want to quickly plug something I've made, because a lot of people always ask me, well, you have a donate function, but I don't have any money and I want to support Brackies, so what can I do? And to help you support me, what I've done is I've made a wallpaper pack like the one you see here. And you can download them at brackies.com/wallpapers if you want to spread the word about Brackies as just plain show off. And there are a lot of cool wallpapers here. You can see some of them here, and you can download all of the HD versions. So please go ahead and do that and set them as your desktop background. I'm sure it will help spread the word. So cool, now that we have the introduction out of the way, let's go ahead and open up Unity. So first thing on our list is the ball control script. And this is because we have some kind of clunky logic in there that I just want to clean up. In the last video, I went ahead and did something that was way more difficult than it had to be. And that was because I was experiencing some problems with the onCollision enter function, but those problems are fixed now, so we can go ahead and clean up the script quite a bit. So first thing to do is we want to get rid of all of this play once. No, not that one. Yeah, that one too. So first off, let's clean up the audio. I think that'd be best. So we can just get rid of this play once variable. Because instead of doing all this play once checking, we can go ahead and use the onCollision enter. So delete the variable, delete all the places that it's used, also the play once true function. So delete that, delete the function itself down here, and delete the if statement here. And there, we should be good to go. And now we take all of this audio logic here and we just cut it. So Control X or Command X if you're on a Mac. And then we make another function called function onCollision enter. And we open up some brackets. And in here, we'll just copy all of this. And if you select all of it and do Shift Tab, you can move everything backwards. So now this will just be much simpler. We don't need to call all kinds of different functions. It will simply play the sound whenever it collides with something. Cool. Now in the onCollision stay, we are gonna change this because onCollision stay is not always that reliable. And the problem right now with jumping is that if we, for example, let's say if we go into Unity here and hit, whoops. I forgot to, so there is the play once. We need to delete that also. So just delete every trace there is left of the play once variable. We don't need it. But if we go in now and hit play and we jump up to a side, so I might not be able to hit this, but if we just collide with the side of the ground, we're able to jump again, like this. And that's not really something we want. We want to make sure that our player stands on the ground when he's able to jump. So a good way to do this, and this is also pretty easy, is just to delete this function onCollision stay, delete the isFalling variable, again delete all traces, and the variable up here. And instead of that, let's make a new variable. So we're gonna call this dist to ground. So that's for distance to ground. And it's just gonna be of type float. So it's just gonna be a number with decimals. And this, we're going to declare that in the function start. So let's make a function start here. And inside of this, we're going to write dist to ground equals collider dot bounds dot extends dot y. So basically what we're doing here is we're getting the distance from the center of our object to the outer boundaries of our collider. And this way we can check if we, by sending out a ray, by sending out a line downwards, we can check if this line hits something within or over the our distance to the ground. So we can basically say how far are we from the ground, and so therefore determine if we're standing on it. So if that all sounded too complicated, I'm sorry. Just follow along here and it might make sense in a bit. So we're just gonna say here that we are getting the distance from the center to the ground. That's what we're doing there. Cool, so let's go ahead and make a separate function down here. And let's call this function is grounded. So this function is something we want to call whenever we are checking if we are standing on the ground. So just close off the parentheses and then do of type Boolean. So that's what we're going to return. So that will allow us to check if we are grounded by calling this function. And then let's open up the brackets here. And then we want to write what we're going to return. So just write return. And then we're going to do physics.raycast and then transform.position. Whoops, that's a small t. Transform.position, comma, minus vector 3.up. So we're just going to shoot downwards. That's why we have the minus, comma, dist to ground. And then we are just going to do plus something small, just like 0.1, because then we are going to make sure that we account in stuff like rounding errors and such. So we're just going to make sure that it will actually return the right value. So cool. Basically what we're going to do, we are doing here, and I know it looks pretty weird, but all you need to understand is that we are making a function called isGrounded, and we can call this to check if we are standing on the ground. And what we're doing is we are sending a line down from the center of our ball. So if I just browse back into Unity here, we are sending a line from the center here and then down, and just checking if where it hits is inside of the boundary here. So that's simply all we're doing. And so if it is, it will return true, and if it's not, it will return nothing. So what we can do is up here, instead of and is falling is equal to false, we can simply say and is grounded, like this, and then two parentheses, and that's it. So now when we go in, hit play, we can see that it's working just like before, but now when we hit the sides and stuff, we are not going to be able to jump, and it's just overall better practice to do it this way. Cool, so now that we've cleaned that up, I hope it wasn't too confusing, but it's just a good way to do it, and I just wanted to show you the correct way of doing things per se. So if we're just gonna write, let's say a little description here, we're just gonna do check if we are on the ground, return true if we are, else return null. Cool. So what we can do now is we can go ahead and find the next thing on our list. So here. Yeah, so next is the ball scale. I just think that our ball here is a little bit too small when we hit play. It's just pretty small on the screen, and this is a matter of preference, but I would just like to bump it up to something like 0.3, 0.3, 0.3. So, and now we might fall through. No, we didn't, but I'm just gonna move it up a bit so we are sure of never falling through the ground. And yeah, I just think that looks a little cooler. And that was basically it. So that was a fast one. Next up is that we're gonna apply new materials. Now, the material we are using right now, let's just go ahead and find it for our ball, is the ball wood. And there's nothing wrong with this material. It's just a simple diffuse material. And of course we're using a diffuse because if we use the specular, we would get these glowing effects, and that doesn't really appear in wood. Wood is very diffuse, so we are using the right shader, but we are only using one image, and that's the normal color map or diffuse map. But what you can do for added realism is you can use multiple images. And for example, you can use what is called a normal map. And that's basically the same image, but with different colors that tells the computer what is high and what is low. So it will help light bounce off the object in a more realistic way. Because right now light bounces off the same way no matter where on the object. But you know, there are some things that are higher and something that are lower on this image. So if we convert this into some data, the computer can more realistically calculate lighting. So what we can do is we can add this normal map, and it's something that you can generate with a bunch of different programs. I've gone ahead and made some in Photoshop here using NVIDIA's tool, the normal map filter. So you can go ahead and download that if you're using Photoshop. There are also some free alternatives for GIMP, or if you want to generate some really easily, you can buy a plugin like Crazy Bump or NDO2 if I'm not mistaken, something like that. But just go ahead and write whatever solution you're using, and there will be a guide showing you how to make these normal maps. But I've of course generated some for us. So if we go under the Mac assets, and these are of course available at brackeys.com, we can go under the textures, and now there is both the medieval bricks and a medieval bricks normal, and so also one for the rough wood. So let's just go ahead and import both of these at the same time. Import them into Unity. And let's go ahead and apply this. So first off, let's find the material here on the ball wood. And instead of diffuse, we're going to change it to bumped diffuse. So that's going to take in a normal map. Now you can see there's an extra slot. And you need to make sure that the tiling on these are the exact same. So I've already gone ahead and set the tiling to the same. If they're not, things are going to look very weird. So just make sure that they're the same. Cool, and now we can drag in our rough wood texture. And you can see that right now it looks really weird. And that's because our texture is not marked as a normal map. And it will also tell us this down here. So you can either hit fix now, which we're gonna do, or go into the rough wood and change the texture type to normal map. But let's just hit fix now, and Unity will do it for us. So now we can see that light bounces off a little more realistically, especially down here in the shadowed parts. And you can go ahead and change this on and off if you want to see the effect on or off. And how, how effective this method is depends on how you make your normal map. So you don't want it to be too apparent, but it's a matter of preference, and I've generated this to be pretty subtle. But let's just change it to diffuse, and you can see things are a lot more smooth And if we change it back, light is a little more realistic. Cool. So now that we have that done, let's continue to the next part. So we are also going to add the medieval bricks, but we are going to add them to the new ground model I made. So that's the next point. That's the new ground model. So again, if we go under the Mag assets and then go under models, we can see that we have a model here called the platform. And we have this in both the FBX version and a Blender version. So unless you know what Blender is and have it installed, we can just simply import the FBX version. If you are familiar with Blender and maybe want to make some changes, I've just included it so you can play around with the file. Basically how I made this, and I'm gonna very quickly show you this in Blender, just because it's so easy, is first off, when you open up, you delete the camera and the sun. Then you take the cube, you go into edit mode by hitting tab. Then you scale it by pressing S, and then Y to only scale on the Y axis. Drag it out and click. Then scale, and then Z to scale it down on the Z axis here. And then what we can do is, now that we have the overall shape, we can go to the right hand side under the modifier panel, hit add modifier, then bevel, and this will give it these cool rounded edges, but we're just going to bump down the width a bit to something like that. And then we're going to set the shading over in the left hand side to smooth. Then add another modifier called the edge split, and then apply both modifiers from the top to the bottom there. And then the last thing you want to do is you want to unwrap the UVs, and we can do this without adding any seams because the model is so simple. So simply go into edit mode and hit U and then unwrap. And now we can add a seamless texture. So that was basically how I made it, and I just wanted to really quickly walk you through it so you know the different steps. Awesome. So let's just import the FBX version here. So let's just, maybe we should make a separate folder for this. Yeah, that will be pretty good, I think. So let's make a folder called models. And inside of this, we are just going to import the FBX. Click and drag, and there it is. We're going to change the scale factor to 1. And then we are going to disable import materials. And yeah, that should be pretty good. Everything looks nice. If you're going to generate a light map, you need to check the generate light map UVs. But we're not going to do that, and we're going to add colliders ourselves. So hit apply. Under the rig, we want to set this to none and hit apply. And under the animations, that will be disabled when you set the rig to none. So now we can go ahead and drag this into our scene. And you can see that it already looks really nice. So what we can go ahead and do is we can make a material for it. So let's disable the other ground here. Let's just delete that. So we can work with this. Let's position it correctly. Something like there. Looks pretty good. And what we can do is we can go ahead and find our material, our ground bricks. And let's also delete the other grounds here. So just get rid of all of them. And then let's just drag the ground bricks on here. But as you can see, the texture is pretty stretched. And that's because our tiling is currently at 5 on the X and 0.5 on the Y. So we're just going to make that 1, 1. But now you can see that the texture is way too big. So instead, let's do something like 5,5. That should give it the effect you're looking for. Yeah, that looks pretty good. And then we can go ahead and change this into a bumped diffuse. So let's now find the normal map and drag it in here. Hit fix now. And we can see that this looks really cool. So now that our ground looks much better, we can delete the old ground prefab and drag the new platform into a prefab here so we can distribute it all over our scene, making the game a lot more fun to play. So let's just duplicate this, move it over Just gonna quickly make a few copies here. And we'll call it that. See, we could maybe do something like this. Just make sure that they all have the same Z value. And if you forgot to change it, you can just select all of them and input 0. So there. This looks pretty cool. So let's go ahead and hit play. And watch our... Whoa! What happens? So, of course, we need to add a collider. And this is where it gets really great that we made it into a prefab. Because now we can just select one of them. Hit add component, physics, box collider, and then everything looks nice. So we can just hit apply, and all of them are going to have box colliders. So now when we hit play, we're not going to fall to our death. We are going to be able to play this, and everything works. And this is actually quite fun. So of course you should do something more exciting with your level than I have here. But it's a start, and it's just to show you the overall principles. Cool, so that was pretty much it for this video. We're just gonna wait with the last thing here, the music reset fix. It's not that important, and yeah, we're running out of time. So that's pretty much it. Let's just, for the last thing, let's make the GM object into a prefab by dragging it down here. That's just something that has been bothering me a bit. So yeah. That's it for this video. Thanks for watching, and I'll see you in the next video.